Okay, so we are going to just quickly talk through this thought development from a perspective of first just saying, okay, if I have y equals 2 to the x, what kind of function is that? Yeah, a little louder. Yeah, that's an exponential function. So if you don't already have that and you think you might forget, just jot it off to the side. When I crank out these values by putting in these x values, will you give me some answers, please? 2 to the negative 2 is 1/4. 2 to the negative 1 is 2 to the 0, 1. 2 to the first, and 2 to the second, 4. And in the air, when you just draw it, what does an exponential look like as a general rule? Right. So I'm going to have essentially an exponential curve where I have these values that are getting up to the left, closer and closer to what? 0. And as I go this direction, as I go to the right, my values are increasing exponentially, pun intended, because that idea of exponential growth is happening in this picture. We are multiplying every single time from term to term. If I said, hey, what's the domain of this, what would you tell me? Yeah, all real numbers. Why? Just logically, I can plug in any single value for an exponent. There's no rules as to what exponent you plug in. However, what is my range of this? 0 to infinity. Why? Why is my range of an exponential 0 to infinity? The asymptote is a result of the range. Why? Why is it not, as an original base function, why is it never going to be lower than 0? There is no power that I can raise 2 to that will cause a negative number. That's why my range is from 0 to infinity. Now, yes, the result is an asymptote. And without any shifts, I have an asymptote where? At 0. So I have a horizontal asymptote at y equals 0. But if you remember how you were essentially taught this in Algebra 2, it was stressed to you that in an exponential function, I am inputting an exponent and getting out a value. But the problem is, what happens when I have to solve for the exponent? So for example, if I'm just given a basic expression and I'm told, hey, I've got y equals 2 to the x, what happens when x equals 3? You could just easily put in 3 and get 8. But the problem becomes, what happens when I'm told, hey, y equals 2 to the x and y equals 8? Yeah, because I put in 8 equals 2 to the x. And my issue becomes, are we listening? This is why we need this in the first place. The issue becomes, this is all well and good as long as I can see the answer. In this case, I know that 2 to the third is 8. But what happens when it's something like 2 to what power gives me 6? It becomes a lot harder to deal with that. So someone came along and said, you know what, it's no longer just sufficient to have an exponential where I input the exponent and I output a value. Now we need the inverse so that I can input an exponent and get a value out. So that's fine. So first of all, notice the idea behind this is that we are creating an inverse that allows me to switch x and y. So tell me, give me an example. Here was my original. Give me an example of what an xy ordered pair would sound like if I switched the x's and y's. What would the first one read if you switch the x's and y's in the first table? 1/4, -2. Give me the next one. Yep. 1/2, -1. Then 1 0 and 2 1 and 4 2. First of all, notice, what were these in the previous table? They were my what? My x values that went in for the what? in the previous equation, where did I put those x values? In for the, I can't hear you. Well, yeah, but where was the x? In the exponent. So before I was inputting, listen to this, before I was inputting the exponent and getting a value out. But now, the exponent is coming out. I'm inputting some sort of power value, and I'm getting the exponent out. Yeah. So, why is that? Well, because what happens is someone came along and said, okay, we know the rules of an inverse. The inverse is just simply that my x and y switch. This is the inverse of my exponential. But that doesn't help us until we get y by itself. So, literally, someone created a log. They created a logarithmic function to say, hey, if I take this log of both sides, I can say that y is the log base 2 of x. Now notice this blue line here and this black line here are equivalent statements. These two right here are my inverse of an exponential. But the difference is, this allows me to find the log. Now notice, again, my inputs are going to be all these values here that we said for x. And my outputs are my exponents. Off to the side, write this phrase. I always tell my Algebra 2 kids when I teach them, a logarithm is an exponent. A logarithm is an exponent. When I get an answer, that is an exponent. Let's write that down. Now, there are graphical implications of this, but they follow the same pattern of an inverse. Do you remember the rules of inverse graphs? Graphs of inverses? What do they do? What do they do? If I graph a function and its inverse, the x and y switch, what would you notice about their graphs? They reflect about the line y equals x. So when I go to graph these points, I have 1/4 -2, 1/2 -1, 1, 0, 2, 1, 4, 2. But not only have my x and y reflected, what else reflected? The domain and range. So now the domain of this logarithm, this green graph right here, is now what? Careful. No, it's reflected. From what? Yeah, because keep in mind, my inputs for this were the outputs for the previous. What's my range? That's right, because domain and range, what? Switch. Okay, what else is switched? One more characteristic. Yeah, what was a horizontal is now a vertical asymptote at x equals 0. Why is that? Let's clarify for a quick minute. Why is that? Why does it make sense that I have a vertical asymptote?
Because you can't put something in for...
That's negative. That's right. If I couldn't get negatives out before, then I can't have negatives to put in. So just have that on your radar as well. Now, we're going to start to remind ourselves how the basics of logarithms work. We got 30-ish minutes to remind ourselves of the definition, the solving, the properties. We're going to crank through these. I'm going to just for each one of these major examples, I'm going to show you one, remind you, and then what I'm going to ask you to do is really, I would prefer work with one or two other people because I think you'll get more out of it. But we're going to go pretty fast. The basic big idea that is embraced here in the blue line and the black line is the definition of a logarithm based on what's referred to as, watch this, if you need to label this. You're taught in Algebra 2, this is your logarithmic form. Obviously, it's got a log in it. This is your exponential form. Reminder, b to the y equals x. So depending on who your teacher is or was, some of them, I never remember how this works, but there's some cheesy snail thing. Anyone know this? Like this base right here to that power gives me x. No one knows this? Okay, good. That's good. So we've got the basic understanding that that base to that exponent equals x. So with that in mind, we're going to talk about how to evaluate one of these, and then without a calculator, you're going to try to do the remaining 4. So a couple things to think about. I've got log base 2 of 8. Now, you likely know the answer to that. What is it? Right, we kind of just said it a second ago. But if I'm stuck, what's a little mini equation I could write off to the side to help me? Yeah, a logarithm is an, say it, exponent. So what I know is that that base to an exponent is 8. Answer, x equals 3. Okay? So you're going to now work. Just try to go pretty quickly. We'll go over these so that you understand them, but if you understand them quickly, it'll be awesome. Okay, go. Hey, either start talking to each other about this or I'm going to put you into groups, which I know you would prefer not to be. Thank you. Let's get going. Come on. Share with each other. What do you got? Hey, what's the power as a square root? What power is that? Half. Yeah. What on? Okay. That is how that works. We had an issue with the term earlier. Okay, how about one more minute? How many people full on remember all this? Okay, that's not too bad. Okay, hey, so Isaac, you're going to talk to Alex and McKinley. Sophie, you're going to talk to Sophie and Michael. Lily, you jump back there and go with Sarah, John, and David. Hannah, go with Aurora. Jump over here if you would, please. And then let's go Chloe. Will you scoot that way and go with Ryan and Andrew? Ben, come over here and go with Michael. Alex. Actually, go ahead and move if I've told you to move, and then I'll adjust the last couple people. Okay, compare those answers real quick.
Three. And then I got -2, 0.
Yeah, that's what I got.
Yeah.
Because I think when it makes this square root, you have to get half.
Okay, okay.
Yeah, so it's automatically like when it does like the.
Yeah, fraction makes it a square root. Because I tried 5 to the -half for that C. And
Alex,
it
you going
gave
next?
2.
Yeah.
Okay, ready? Here we go. How about John Basil? Letter B, answer. Yeah, 1/2. Are we okay with that? I'm gonna keep going if you're fine. Okay. Log base 5 of 1/25, then. No, you were right before.
-2.
Yeah, -2. Very good. We okay with that? Next, Sophia, letter D. Either Sophia, actually. 0, good, because 4 to the 0 is 1. And anybody on the last one answer? 1. Very good. Okay. So now on the next page, I'm going to go through this one a lot quicker. I'm just going to remind you that all the properties of a base of a positive number therefore apply to a base of e. So really quickly, as a reminder, the logarithm that is unseen, if I don't see it, it's an assumed base what? 10. That's considered a common log. So the property is here. When I don't see it, 10 to the y equals x. a base that's unseen happens not only in a common log, but in a natural log with a base of e. Now, I'm just going to tell you for time's sake, we're going to do this one together. The properties do not change. Do you remember what the base number is for e? Do you remember what the digits are? 2.71828, right? So the idea is somewhere between 2 and 3. So you know these basics. E to the 0 is 1, right? Because that's true no matter what the base. What e to the first, we'll just put it as e to the first, that's e to the second. Well, if I go here, there's 0, 1. Here's 1 e to the first. There's 2. It's up in here somewhere. Point is, I don't even totally care where exactly it is because the properties are still the same. What's the domain still for e to the x? Say it again. Yeah, this is an exponential function. Domain is all reals. What is my range? Yeah, because if I were to go back the other way, you with me? This would be 1 over e. Well, that's 1 over 2 point something-ish. So that's negative 1 in here somewhere, and negative 2 in here somewhere. This is still following that same pattern as the previous page. Now, we know, if we had time, we're not going to do this, but if we had time, we could have not only exponential growth, but exponential decay. Do you remember under what circumstances you have decay? Yeah, when my base is between 0 and 1. But we're not going to worry about that. We're going to focus more on the logs, okay? So, for the record, however, just don't miss the fact that a base of e still has that horizontal asymptote at y equals 0. So with that in mind, with whoever you're working with, all I want you to do is take these values, swap them, and plot them. You don't do anything in the middle. Take these values, we're going to find the inverse of a base e, swap those ordered pairs, and plot them over here.
What is negative 2 and
1 over e squared. Like, I didn't even find the value, really, because I don't, it doesn't totally matter, because it's just following the same patterns as before. Okay, everyone clear what you're doing? Swap the ordered pairs, plot them, go.
Let's make that gravitation.
Yeah, for sure. Okay, in the y column, what do those represent now? Okay, x is from before, but they are the output, which are exponents, right? So I've got negative 2 to 1 for time's sake. Are you ready to go? I'll give you a minute, sorry. I'm going too fast.
Is this the same thing as the last one?
It would be,
Yeah, it looks
just
like-
reflected across that.
Yeah.
Or y equals x.
Domain
Can I ask you a question
is
from
0,
For what?
Yeah, 0 to infinity.
Yeah.
No.
It's a simple question,
X
and
infinity.
the answer is
Slightly
well.
different from this graph. You've got exact values. But it's a vertical x. Since you
Oh,
Okay.
okay.
Okay, so all I'm going to do is plot these. As you should notice, it looks, I heard someone say, is this basically the same? Yeah, absolutely. So for the record, that goes through 1, 0, even though you can't see it very well. Terrible graph. Try it again. And a couple other quick things that we want to be able to list. What's my domain of my new green graph?
0 to
Okay, what's my range?
all.
All real numbers. Why? Because the domain and range of the previous exponential with base e just what? Flipped. Now I have a what kind of asymptote? At x equals 0. But let's just quickly clarify what we have found. I've got y equals e to the x as my base function. When I go to find my inverse, what do? Switch x and y. And then what? Yeah, I need to solve for y. And when I solve for y, I'm technically taking the log. So to be clear, the actual steps would look like what Lily just said. I take the I take the log of base e of x, the log base e of e to the y over here. But notice, this is just what? What is this expression equivalent to? Y. And then here's what someone decided. Likely most specifically because the idea of a natural log exists literally in nature. So depending on what kind of sciences you have taken, one of the big conversations is like from a element perspective and how an amount of some sort of element decays over time. That's one of the big situations that is dealt with regards to natural log. Natural log allows me to express the decay of that element. So someone came along and said, you know what, let's not call it log base e, let's give it its own definition. And like a common log, you don't have to list the 10. With a natural log, you don't have to list base e. So this blue line and that red line are equivalent because this is base e to the y equals x. With your groups, based on that, answer A through D. Go. It might help, because I hear you a little quiet this time. It might help if you write that. And I will say, when I taught this again this year in Algebra 2, some of my kids hated writing natural log, so they would write log base e of e, because it just helped them feel better.
Yeah.
So you can. You don't need to, but you can. Okay. And
Wait, so none of these have
Yeah.
what?
none of these have
That's just log base
Yes.
e of
Yeah.
3.
So for natural log, I don't need to
Yeah,
write base.
maybe log base e e3.
Base e.
What's it?
Look like what?
Like,
Oh, yeah.
I don't really know. I don't understand. I never understood that. So like I get it, but I'm
That's what I'm used to.
still
You got it. If you're as far as you can get, raise your hand. Okay, all right, here we go. So this is obviously harder, right? I personally taught Aurora, and I think this is super valid. I heard her say, I never really totally got natural log. I think that's totally normal. And so I'm going to try to fine-tune some of this right now. I'm going to say again, however, I do think some of you benefit from just switching from ln, because people get stuck in that ln, to log base e. E to what power? Just literally bring it right back to that definition. E to what power equals e? 1. Now listen to this. E to what power gives me e to the third? 3. But if you need to, write a little mini, what's that?
How do you write that out?
Yeah, I'd say write a little mini equation. This is base e. You can't see that because it's in a weird spot. But this means this expression from a logarithmic perspective to a exponential definition means the base to some power equals e to the third. So what does x have to be? 3. Okay?
How would you write that out with log? Would it be log base e to x equals e?
If you really need to stick to that black line right there, the only change you're making is the ln becomes log.
Right.
That's the only thing. Everything else is the same. Okay, what about this one? Do you think now you can explain C when you raise your hand? Oh, good. Okay, go, Lily.
It'll be negative 1.
Yeah, why?
Because if you think about like log base e, and then it ends up a fraction, and e is on the bottom.
Yeah. So if you need to write the mini equation, this means e to some power equals 1 over e. I think it helps if you say, oh, if I put it in the denominator, that means the power on it must have been negative. Is the answer? -1. And Ryan, you got the last one?
Yeah.
Yeah, it's just like the one on the front, right? This is e to what power equals e to the 1/2. X equals 1/2. Okay, now, with that in mind, I'm about to rapidly remind you of the properties. You ready? Am I right? Okay. All right, so on the next next page, you're reminded of the properties of logs. And this is a straight up, for those of you who are going to take calculus next year, this is a straight up skill you're going to need realistically a chunk. So, a couple quick reminders. The log of a single product is the sum of two logs. You see that top property? The log of a single quotient is the subtraction of two logs. And then when you have a power on the log, it can come out as the coefficient. Now, we're going to do one of these together, and then I'm going to have you try them in your groups. I would consider this the log of a what? Base 10 and log of a product. So I think it, cheesy as it might feel, I think it helps to go log of 8 times x times y to the 4th. Okay. Now, this says, hey, if I've got a product, I split it up into the sum of 2. I do not think the step I'm about to show is something you need to show every single time, but I do think it helps. So this is log of, well, I'm just going to do products in 2 steps. I've got an 8x, so let's keep that together. And then I'm going to add it to the log of y to the 4th. Okay? Now, what's going to happen there? This 4 from the power rule is going to do what? Kick out in front. 4 log of y. But I'm left with another product. So what do I do to this log of a product? It becomes the sum of, a little louder, Ben?
Log of 8 plus log x.
Log of 8 plus the log of x plus 4 log of y. Okay? This can go both ways, however. So when I am given natural log of x to the 5th minus 2 natural log of xy. What do you think I'm going to do to, instead in this case, condense this into a single log, natural log? Say again? I just literally can't hear you. Put them over one another. What would you put over one another? Almost. What do you think? Yeah. Yes, it's going to be squared. So the one thing, think of it in terms of order of operations. I've got this essentially as a coefficient is really an exponent, and just like in order of operations, I have to deal with exponents first. Let's do that first. But then if you heard what Holly said, she said it perfectly. She said, hey, take this and put it over this. Now, for the record, you always want to simplify these. Do you know there's any way I can simplify this?
Yeah, it's just x3 over y.
Yeah, because it's going to be x to the 5th over x squared y squared, which is going to give me natural log of x cubed over y squared. There's my final answer. Okay?
So you don't do natural log on top and bottom, it's just outside of the fraction.
Right, and if you, the one thing, like, so when I teach it in Algebra 2, I make them say stuff all the time. So I make them say the difference of 2 becomes the quotient of 1. So you never can go from 2 to 2. It always has to be 2 to 1 or 1 to 2. Does that make sense?
Mhm.
Okay. All right, so with your people, will you do B, C, B, and C? Go.
It's log.
Both BCs.
Yeah,
Both BCs.
Squared as well.
Yeah, so it'd be 2 log x minus 3 log y.
That's right. Does 9 just get rid of that, the x squared?
so I would suggest for the most part, like you can look up here when you're ready, but I would try to not look until you're desperate. And then I'll kind of wander a little bit.
And this use log. Exit their time.
Okay, anyone need more time? Okay, have you checked? What's that?
Are you gonna give us this one?
No, you got it all. And honestly, I would just say again, mostly because I just know what's going to happen in calc. The second you get into calc class, they're just going to assume you need to know this. Or you already know it. How about 30 more seconds?
Log is X.
Okay, so where are we looking?
Yes.
Still not, I don't know how to apply it to these two.
So this is, if that's an F of 3, what would somebody do?
I put 3.
Yeah, it's usually the pleasure. That's it. Ben, you okay?
Yeah.
Okay. Anyone else need more time? Because I'm going to go. All right. Next. I feel like you've got a question. You sure? Okay. All right. So, in the long run, one of the primary purposes of the development of a log is to solve equations. So, I'm going to go in reverse order, actually. And we're going to first just deal with the basic definition of a log. If I'm giving you log base 4 of x plus 3 and I said, hey, it equals 2, what's a fast and easy way to get this into an easy equation to solve? Yeah, this base to that power equals that. Okay, so what would I do? If this seems easy, it's because it is. What would I do? 16 equals x plus 3, last step. Subtract 3, that's right. Okay? Now, in these two, which you're going to try here in a minute, what are you going to have to do first? Yeah, I'm going to need to condense this, and I'm going to need to apply a property here. Okay? But for now, before we do that, let's jump up to perhaps one of the primary reasons a logarithm was created in the first place. If this said 16, 4 to the x equals 16, you would just have an answer. What would that answer be? 2, right? Now the truth is, I do know that my answer is a little less than 2, but we're going to need an exact answer. So you likely remember this. If I've got to get that variable out of the exponent, what do I do? Be specific. I needed a better phrase than that. Say again? Yeah. I teach it as take the log of this side. If you heard what Lily said, she said, look, take the log of that base. But if I do that on the left, I have to do that on the right. Well, both your understanding of the definition and the property tells me that that left side just simplifies to x. This can be found in your calculator. Put it in there, please. Just shout it out when you get it. I don't really know off the top of my head. 1.95. Okay. Now, perhaps the trickiest one is going to be letter C. So hold off on that. We won't do that one until tomorrow. Okay? What I would like you to do really quickly is B, B, and C. Go. with each other? What are the steps that you're taking? If you're stuck, raise your hand and I can help you. Motivated. I'm really asking you to go through for a minute. Are you stuck? Well, what do you think you're doing first?
672.4.
But I would get your
Try it.
So you have to get the X away.
Yeah.
You gotta take a lot of that whole
About what?
40, just get rid of 40E. Just take a lot of 40E. And then we got this negative.
Right. You actually can't. You can't take that. Right. You can't take the natural log of all three of those. So the catch is.
It's like it's always in one folder. So this one we do is log 40E. And then we got to log 40E.
Okay, because I want to make sure that you can work on this for homework. A couple quick comments. Letter B here in example 5. What am I going to have to do first? Yeah, I got to get rid of that 40. E to the 0.6x equals 6. Here's the reason, primary reason. I cannot take the log of both sides until I have a base by itself. If you think you're going to forget that, star it. Raise your hand if you need me to say that again. Okay. So, do I need to take the log? What else could I take besides just the log? Good, natural log. E to the 0.6x equals natural log of 6. What does this simplify to? Good. And this is a number. What's my last step? Divide by 0.6. That's right. If you have an answer, will you raise your hand? Ryan, what'd you get?
2.99.
Okay. Are we okay there? Okay. In letter B, what am I going to need to do first? Someone said it before. Yeah, turn this into the log of a product. This is log base 2 of x times x minus 7. So then, what do I need to do? Yeah, I refer to that as applying the definition. When I apply the definition, I say 2 to the third equals x times x minus 7. This is 8 equals x squared minus 7x. Guess what that's code for? I'm going to solve a quadratic. So I'm going to get one side what? Equal to 0. Now, one quick comment. This factors to what? X minus 8x plus 1. So my two answers are 8 and negative 1, yes? No. Why can I not include both those? I cannot take the log of a negative number. And when I plugged in negative 1 right there, it would make it illegal, right? It's considered an extraneous root. Okay, you picked up a packet. That packet is due tomorrow short of 22, 23, and 24.
Are you checking this one tomorrow? Because really, we're not looking at it.